Good morning, everyone. Welcome to week 2 of the quarantine. Week 2 of the quarantine. Sorry, love the stream unmuted. Yeah, good morning, Cooper. Yeah, good morning. It can be a good morning, right? Just had a tiny little aftershock. Did you guys feel that one like 10 minutes ago? The quarantine, Tyler. Like I said, I said this a little while back. I think as soon as they called quarantine, I'm thinking through spring break. So definitely through another 3 weeks. So yeah, I'm thinking another 3 weeks. So we'll be doing this at least for the next 2 weeks, and then spring break, which they're still gonna do it. So not a real outro, Cooper. Just like a see you later. No, they haven't officially extended it yet. This is just me supposing. But yeah, they were gonna reevaluate at the end of this week, so we'll look for an official announcement at the end of this week. We'll have to see what everybody says or what things are going on. Yeah, you'll be all right, Valen. What's the end like? Weekend? I don't understand your question, Lauren. Yeah, Ellie, potentially, right? There's a lot of people that are thinking this will just last throughout the rest of the school year, which I think is a little intense. But it might be where we are, so who knows? But definitely this week, we will definitely be doing it this week. So this week for sure. Everything else we'll just have to wait and see what people that are in charge decide. So yeah, at the end of the week. Oh yeah, sorry, Lauren. It's probably they would probably put something out Thursday or Friday. Um, yeah, we'll see. I don't know about Eliza, but for sure, probably earliest people are thinking is maybe May. I would love to have the last month of you guys actually back in class. But yeah, for sure through spring break is my bet. We'll see. We'll see. People are calling you out on that bet, Eliza. 12 to 24 months. Yeah, there you go. You got it. Sure, we'll allow that. We're gonna worry about all that stuff as it comes up, Lauren. Don't worry about that. Don't worry about that for now. Yeah, I don't know what they're gonna do yet. We haven't decided. I just know that now we're on week 2 of being quarantined. So yeah. Yeah, I'm tired. Yeah, I know, Trinity, but it's only it's only been a week. My kids are both. My wife went to the grocery store this morning. She's gonna see if she can find some food. So we'll see how that goes. I'll have to talk to her when she gets back. Um, yeah, and yeah, they were allowed to do that as of now. I mean, you shouldn't be having to go in like every day. Maybe once a week or so. Yeah, but requiring you to come into the school every day is a little ridiculous. But once a week makes sense to grab stuff or put things in. A lot of teachers are just doing everything like on paper or by hand. I for my AP class, we're gonna start doing practice tests, and so I'll probably print those and have them come pick them up. You should still be able to get into the school, Eliza, if you need to. The school should be open. I think the last email I got said 7 to 3, but I'm not sure. I'll have to double check. Yeah, go in the front doors. Yeah, I had an email about it. I don't remember when it said. Hunter, that's still too far away to have a full decided on if there's going to be graduation. Everything's kind of just like a take it as we see it. Oh, thanks, Mr. Weaver. Yeah, so school's open from 7 to 3. Yeah, real quick, Lauren, what's your question? Yeah, Izzy, you can park wherever you want. They're not going to enforce parking and things like that because you'll just be going in and grabbing stuff. Oh, I need to make Mr. Weaver a mod. Oh, sorry, a moderator. A moderator. Do another attempt to quiz will make us 3 types of questions that aren't multiple choice. I think so, Lauren, but you can't just copy and paste your answers from previous attempts. So what I would do is maybe like type them somewhere else and then just copy and paste them in. So yeah, unfortunately, you do have to do the multiple things. So yeah, what I would do on those, if you're gonna do multiple attempts, I would maybe save the short answer ones for later, or maybe put those other ones over there. Canvas is due tomorrow, Tyler. I think I just updated it to where it says tomorrow. It should be tomorrow. Those ones due tomorrow. No, I changed it to be due tomorrow, Cooper. I just changed it this morning. Because, I don't know. I just want to give you guys. It's a good meme. Yeah, so Canvas is due tomorrow. I'm going to do, so like I said, if you could notice my to-do list in the bottom left, I'm going to upload the grading key for 11 and 12 so you can check that. And then I'm going to post the test, which you guys can just do kind of on your own, open notes. It's not a big deal. So, yeah, tomorrow at 11:59 p.m. Tiara. So yeah, Zach, that's Roman numerals 11 and 12. So I'll put the grading key for that. I'll do that today so you guys can have that and look at it. Lauren, the test is just going to be open on Canvas for you to do by Sunday night. I'm just going to upload all my questions to Canvas. I'll do that today. So then once, because this is the last thing we have for this unit. Yeah, you can use your text, you can use your notes, you can use your homework. I'm going to just, it doesn't matter. I don't care. Of course, don't use other people and don't use Google, but you can use your notes or your text. So yeah, open note, but no Google and no friends. Why are all of our things ending so early? I don't know what that means. I assuming you actually try, Drake, you should get an A. That's the hope. So, yeah, Hunter, I'm just gonna have you. I'm gonna give you the grading key and have you just record your score, like for the Strength of Bonds worksheet. I guess, Michaela. I don't know if it'll help you very much. So it'll be just like always. I'll have a multiple choice section, and then I'll have a short answer question section that I will manually grade. So I'll grade the multiple choice is automatically graded, and then the short answer I'll have to go in and manually grade. Can we still correct our worksheets for half credit back? Yeah, Izzy, just send me an email if you ever do something like that, and or a message on Canvas or something, and I'll be able to update it then. The Roman numerals 11 and 12 I'm going to make due Wednesday night, Tiara. So Canvas is due tomorrow. Canvas chapter 14. Or 15, sorry. No literal cheating. Sorry, Goober. No literal cheating. Okay, let's jump into the notes for today. So, this is kind of just this last thing I wanted you guys to tack on to the end of our discussion from Friday, which was forever ago. So if you remember on Friday, we were talking about colligative properties. In particular, we were talking about how the vapor pressure is lowered whenever you make a solution. The boiling point gets higher, the freezing point gets lower, and the osmotic pressure increases. Okay, so we had all four of those things. What I wanted to do is I wanted to tack on just right at the end, more particles equals greater changes. And so what I mean by that is I mean that if you took something like calcium chloride, right, and if you dissolved it, we would get a calcium and 2 chloride ions, right? Lauren, I updated the canvas so you can go in and type those ones now. You might have to use one of your submissions, but you can write words in those ones. That's a mistake on my part. All right, so then we have we can have something like methanol, which when we dissolve does not split. So if you took equal moles of calcium chloride and methanol, and you dissolve them into solution, it turns out the calcium chloride will have 3 times the effect as the methanol for changing things like boiling point, melting point, vapor pressure, and things like that. Because the calcium chloride breaks up into 3 distinct particles, it'll have 3 times the effect. And so ionic compounds that break apart are going to have a greater effect on all these colligative properties compared to things like molecules. So just kind of understand that when you have an ionic compound, it's going to have more of an effect, especially one that breaks up into a whole bunch of particles. Okay. Lauren or Eliza answered that question. I've I updated the canvas. That's another reason why I moved it tomorrow and gave you another submission. If you reload the page, or if you resubmit it, or if you submit what you have currently, it'll refresh it and it'll let you type in questions for those 2 that I forgot to make essays. Yeah, it'll be 2 points off, Trinity. So yeah, so Izzy, it is. It's a direct relationship between the amount of particles and how much it changes. So more particles, greater changes. Okay, let's go to big letter D. So we're going to go all the way back out, big letter D. That's not a very good D. But anyway, big letter D. We're going to talk about the factors that affect solvation. All right. So we want to know the factors that affect solvation, right? So what we're going to talk about it in 2 ways. We're going to talk about it first, factors that affect how quickly something dissolves, and then second, talk about factors that affect how much we can dissolve. So the first thing we're going to talk about is the rate of solvation. The rate So the rate of solvation is affected by... Okay. So if I'm trying to make something dissolve really fast, what kind of things can I change so it dissolves faster? What are some things I can do to make it dissolve faster? What do you guys think? Temperature, yeah, Trinity, temperature. Higher temperature or lower temperature? Hot, yeah, there it is, Ellie. Right, so we want a higher temperature. So higher temperature. And the reason why is because at higher temperatures, right? At higher temperatures, we have atoms and molecules moving around faster. Pressure's a little tricky. We're going to talk about pressure in a little bit. But yeah, higher temperatures. Ooh, surface area. Good, Trinity. That's another one. So for solids, we want increased surface area. Oops. We're going to talk about that, Cooper. We're going to get there. So when we talk about surface area, this is to put this into something more practical. When you take, like, think about a sugar cube versus powdered sugar, right? If you try to dissolve a sugar cube, it's going to take a lot longer than for powdered sugar. No, Lauren, this is true. Well, I guess this is only for solids because surface area is solids. But higher temperature would be true for gases. It would make it faster, but it's going to have another effect later. We're going to talk about more. Okay. Last thing we want to talk about. This one's really simple, but we try to make it sound fancy. We're going to call it agitation, which is literally just stirring. Right? If you stir something up, yeah, Drake, you're actually right on that. So, Anya, when you grind something into a powder, it makes it so that atoms and molecules are more available to interact with the solvent, and so they can dissolve faster. Yeah, you can think about it. More solid particles are available to interact with the solvent. So agitation or stirring, of course, equals faster dissolving. Okay, cool. Good. So that's pretty much it, right? If we want to make something dissolve faster, we can make a higher temperature, we can increase the surface area, or we can stir it up, right? So all three of those are going to make something dissolve faster. Yes, if you agitate your milk and chocolate, it'll go faster. So that's a good question, Faye. So if you think about it, right, you guys know this just from experience, but again, it's the idea that as you stir it, it allows the more solid particles to interact with the solvent at any given moment, right? And so it just forces that overturning of the water to allow for more particles to be exposed to solvent in a given amount of time. Pour powder into water if the powder is in a dry cup. No, that shouldn't matter, Hunter. It should be the same either way. Although some people will try to argue with you and say that it's one way's better. All right, number 2. I don't want to say it. The amount All right, so the amount of solute is affected by now this one actually matters if we're talking about gases or if we're talking about solids. Okay, so let's first talk about for most solids. All right, so for most solids, the amount of solute is affected by, right? So if we're going to make a saturated solution, for most solids, if we want to make a saturated solution and we want to make it so more solute dissolves, the only thing that's really going to affect that is temperature. Right? And the reason why is that your atoms and molecules at higher temperatures, right, have more kinetic energy. And so if they have more kinetic energy, they're moving around faster. And if they're moving around faster, we can get more solid to get dissolved and broken up and solvated into my solution. Okay. No, you're good, Zach. All right. So most solids, higher temperature. Okay. Now gases are a little different, right? For gases, you actually want a lower temperature. Zach, if you reload the page, it should help with the delay. So gases. So for gases, like I said, we actually want a lower temperature. Right? And the reason why we want a lower temperature for gases is basically the same reason as a higher temperature for solids. Okay, so the idea is that if your gas particles are at a higher temperature, right, that means they're moving faster, which means they're going to escape out of the liquid phase more easily. If we get things down to a lower temperature, your atoms and molecules are moving slower, and because they're slower, they actually stay trapped in solution better. When people are talking about this in biology, they often talk about how, in colder waters, similar to evaporate, Lauren, in colder waters you have more dissolved oxygen, which makes your fishies bigger. But yeah. So for gases, we want a lower temperature because less gas can escape. The other thing for gases is we actually want high pressures. We'll say this is a C. Okay, yeah. Weaver brings up a good point. Hot soda is not good, right? If you're going to drink a carbonated beverage and it's at a higher temperature, it's going to taste pretty nasty because everything will come out. If you heat solids and cool gases, is there an ideal somewhere in the liquid phase that maximizes solvation quantity? So Cooper, it actually is it changes from substance to substance. Different substances dissolve at different amounts in different temperatures, and so there's this whole, you have to kind of look up the values and determine all these things based off of everything that's going on, right? And so to say that there's one perfect temperature, it doesn't actually work. But if you have a specific application, right, say you're trying to maximize the amount of carbon dioxide dissolved and you're also trying to maximize the amount of sugar dissolved, there might be some ideal temperature for that. Okay, I want to talk a little bit about this because we can actually calculate this. We can do and there's a couple questions on your Canvas that ask you to calculate this. This equation's in your textbook. It's the idea that S stands for solubility. So the solubility at a certain pressure and the solubility at a certain pressure. Yeah, this is a little I. Solids actually are not affected by pressure, Enya. It doesn't do anything to solids. Okay. Yeah, it's an S for solubility. Okay. So let me show you how this equation actually works. We'll do an example. Right. So a certain gas has a solubility of, let's say, 0.09 grams per liter at we'll say 25 kilopascals. What is the solubility at 80 kilopascals? Okay. Hi, Ainsley. It's okay to be late. P stands for pressure, Tyler. So let me I can put that out here. So solubility, pressure. So what this equation is saying is that if we know the solubility at some pressure, we can calculate the new solubility at some new pressure. Right? Kilopascals is a measure of pressure. And yeah, just like atmospheres, millimeters of mercury, torr, all those millions of ways that we have to distinguish pressure. And so the calculation here is actually pretty straightforward. We just plug into the equation. So we plug in 0.09 divided by 25, right? Because that's our solubility and our pressure. And then equals the new solubility and the new pressure. Okay. And so, no, Austin, why are you watching this stream? So yeah, it's just cross multiply. It's just ratios. You just take 0.09 divided by 25 times 80, which if I grab my calculator, 0.09 divided by 25 times 80, yep, 0.288. So S2, 0.288 grams per liter. Okay. Yeah, but you were being obnoxious. He was actually on topic, Sander. So 0.09 over 25, S2 over 80. So our new solubility is 0.3. Notice, as we increase the pressure, the solubility increased, right, by a pretty good amount. Okay, so by what is that? Almost more than tripling the pressure, we saw a much greater increase in the solubility. Okay, so that's how these problems work. There's a couple of these on your canvas, so I think there's 2, and they're pretty much just like this. So you should be able to do that, no problem. Cool. Now there are a couple. There's a couple. There's a couple questions on the canvas that have to do with like colloids and suspensions and things like that. I figured you guys can just get that from the reading if you haven't done the reading. So no, Zach. For solids, pressure doesn't affect. Pressure has no effect on solids. Pressure does not affect how solids dissolve. The only thing that affects how solids dissolve is temperature. Cool. Okay. Yes, your salad dressing is technically a suspension. I think that's actually all I wanted to do today. So we're going to be done a little bit early. So, yeah, Naomi, this calculation is just for calculating the solubility of gases. Yep. Cooper, don't derail the conversation. So Ellie, 11 and 12, we're down here on the bottom. I'm going to upload the grading key today, and it's going to be due on Wednesday night. Oh, is that where it talks about like suspensions and colloids? Or is that the equation? No, you don't have to know any of the other calculations, Sadie. That's a good question. It's I don't even think I have one of these on the test. The test is a lot more just conceptual, so hardly any calculations on the test. Yeah, I can swing back to that last page, Ainsley. Um, so do a quick recap. Um, so we talked about how this is our last thing we talked about for colligative properties. We said that more particles equals greater changes, and there is a question on the test about this. So make sure that you double check or make sure you understand this. And then we went in and talked about the different factors that affect the solvation. We talked about how the rate of the solvation can be affected by higher temperature, increased surface area, agitation, right? Those three things. And then we went in on the next page and talked about how we can increase the amount that dissolves. For solids, we can use temperature. For liquids, we can use temperature and pressure. Solids, we want a higher temperature. Liquid or gases, we want a lower temperature. Okay. Let's talk real quick about what the rest of the week is going to entail. So we've got the chapter 15 canvas. Oh, it just increases how fast it dissolves, Cooper, right? Because you stir it up, more molecules get kind of mixed up and interact, and so they dissolve faster. Review for the test. Jonathan, because I'm doing the test as kind of like an open note thing, I'm just going to... I don't feel like we need to review. So, yeah. No, my kids are still at the grocery store, Kate. So recap. Let's talk about the test just in case you guys missed it. Roman numerals 11 and 12 going to be due Wednesday night. Okay. The chapter 15 canvas is going to be due tomorrow night. So make sure you get all that stuff done. Yeah, Lauren, you have everything for the test. Assuming you've got the canvas done, assuming you've got Roman numerals 11 and 12 done, you know everything you need to know for the test. So I'll get that uploaded probably today. But again, you can use your notes, Jonathan. You can use your notes on the test. So I might post like a quick outline. Maybe I'll do that tomorrow. Maybe we'll do a quick rundown of what's going to be on the test. We are going to have a stream tomorrow. We're going to dive into the next stuff. You are able to do the canvas sander. And you will, so Hunter, that's a good point. You only get one try on the test. So it's only going to be a one attempt. It's not going to be a multiple attempt. Yeah, Lauren, we are going to stream every day. Although some days I think might be shorter. Like today, I'm going to end in the next 5 minutes or so. But still plan every day to check in at 8:30. Yes, you know all the stuff for the canvas sander. Like I said, there might be one thing you need to check the text for. So the test is going to be due on Sunday, Ellie. I don't have a dog, Drake. So, Izzy, why would you do it late? Just do it before Sunday. Yeah, we're going to be done in the next couple of minutes, Cooper. I don't have anything else to say. So, Izzy, I will remind you literally every day on stream. So it'll be mostly multiple choice. There will be a couple short answer questions. I'm working on how I want to translate it. So we'll see. I'll upload the test probably this afternoon, Jonathan. And so you can start it tomorrow probably. I would wait till you had all your homework done and checked and graded and do all that stuff before you do that. There's not a time limit, Hunter, but you just need to get it done before it's Sunday. Parker, we just talked about that at start of class. More solute, more particles, greater effect on colligative properties. There won't be a time limit, Matthew. Nothing's due tonight, Tiara. Canvas is due tomorrow. 11 and 12 due Wednesday. Okay, I think I got everyone's questions. I actually don't know the history of that, Cooper, but it's a valid question. Okay, cool. So yeah. So more particles means a lower freezing point, Parker, because that's a greater effect. Freezing point depression is one of the colligative properties. As you have dissolved solute, the freezing point gets lower and lower and lower. Ainsley, I talked about this at the beginning of the stream. I think we're for sure out this whole week, and hopefully we'll get an update near the end of the week of what we're going to be doing. My bet is we won't be back until after spring break. Okay. I'm gonna end that here. If you guys have questions, hop into the Discord at noon today. I'll be there from noon to 2, and then I'll get those things posted. So, spring break is in 2 weeks, Johnny. So, all right, later, guys. Have a good rest of the day.